All right, let's just dive right in. When you think about the final frontier, your mind probably jumps to outer space, right? Distant stars, other galaxies. But what if the biggest, most alien world we have yet to explore is right here on our own planet? Welcome to the deep sea.
And this number is just staggering. Over 80% of our own planet's ocean is still a complete mystery. We're talking unexplored, unmapped, and totally unobserved by human beings. It is, without a doubt, the last true wilderness left on Earth.
So, that's the billion-dollar question, isn't it? What is actually down there? Well, that's what this is all about. We're going to take a journey, plunging thousands of meters into that abyss to see what kind of bizarre life, incredible ecosystems, and global secrets are waiting for us in that perpetual night. Okay, so our journey starts by heading straight down. And you have to understand the deep sea isn't just one single place. No, it's a series of layers of vertical zones. And each one gets more and more extreme as we go deeper, as the sunlight fades to nothing and the weight of all the world's oceans starts to build up above us.
As we descend, the conditions just get wild. First, we hit the midnight zone. This is where sunlight is officially gone. Poof. Below that, the abyssal zone. This vast, flat plain that covers more than half of the entire planet. And then, if you go even deeper, you reach the hodl zone, the deep sea trenches. Here, the pressure is so intense, it's almost impossible to wrap your head around.
And here's the thing you absolutely have to remember. Life down there has to deal with all three of these challenges all at once. It's not just the dark or just the cold. It's the combination of total darkness, near-freezing temperatures, and that absolutely immense pressure. These three things create the rules for survival.
And to give you an idea of that pressure, just try to picture this. Down in the Mariana Trench, the deepest spot we know of, the pressure is over 8 tons per square inch. That's like trying to balance a small car on something the size of a postage stamp. I mean, how could anything possibly survive that?
Well, this is where things get really, really cool, because life doesn't just survive down here, it thrives. It has evolved some of the most unbelievable and frankly bizarre adaptations you will find anywhere on this planet.
So in a world with no sun, what do? You make your own light. It's called bioluminescence, basically a chemical reaction that creates living light. And get this, an estimated 80% of deep-sea animals can do this. Think about that. It's probably the most common form of communication on Earth, and it's happening in total darkness.
And this living light is used for everything. It's the ultimate survival tool. For hunting, you've got the classic anglerfish, dangling that glowing lure. But for defense, some tactics are genius. My favorite is the burglar alarm. An animal will let off a bright flash, not to scare away its attacker, but to attract an even bigger predator to come deal with the problem. It's brilliant.
But okay, what about that crushing pressure? How do they not just get squished? Well, the secret is tiny. It's at the molecular level. For one, their bodies are mostly water, which doesn't compress, but the real magic is a special molecule called TMAO. You can think of it like a chemical shield that wraps around their proteins and keeps them from getting bent and broken. It's just nature's perfect answer to a seemingly impossible problem.
Now, even though most of the deep sea is like a vast, empty desert with very little food, there are these incredible pockets of life, just bursting with energy. These are the oases in the void. And what's fascinating is that they're powered by two completely different sources. So on one side, you have hydrothermal vents. These are like bustling cities, just teeming with life, and they run on the raw heat coming from inside the Earth. Then you have the endless abyssal plains. Life here is sparse, quiet, and it survives on a slow, gentle shower of organic bits, called marine snow, that drifts down from the sunlit world thousands of meters above.
And at those hydrothermal vents, something truly world-changing happens. It's a process called chemosynthesis. Seriously, its discovery completely rewrote the biology textbooks. It proved for the very first time that complex ecosystems could exist with absolutely no energy from the sun. None.
So here's how it works in a nutshell. You have these amazing microbes that basically eat toxic chemicals, like hydrogen sulfide spewing from the vents. Then they harness the energy that's released when they break the bonds in those chemicals. And finally, they use that raw energy to create food. It is life, literally being forged from pure chemistry in the pitch black.
Meanwhile, way out on the plains, life plays a waiting game. It's all about that marine snow. But here's the catch. Only about 1 to 3% of the food made at the surface ever makes it all the way to the bottom.
So the real jackpots are whale falls. When a giant whale dies and sinks, its body becomes a feast that can support an entire ecosystem for decades.
Now, it's easy to think of this remote world as being completely disconnected from us up here, but that's not true at all. The deep sea is actually a critical, unseen engine that plays a massive role in keeping our entire planet's climate stable.
And here is exactly why it matters so much to every single one of us. The ocean as a whole has soaked up about a third of all the carbon dioxide we humans have pumped into the atmosphere. The deep sea is the final destination for a lot of that CO2, acting like a giant storage facility, locking it away from the atmosphere for hundreds, even thousands of years. And this carbon gets down there through two main pumps. First, you've got the biological pump. That's the marine snow we talked about, and also animals that migrate up and down carrying carbon with them. Then there's the physical pump, which is this huge global conveyor belt of ocean currents. Cold, dense water near the poles absorbs CO2 right from the air and then sinks, taking it deep into the abyss.
But here's the paradox, and it's a dangerous one. This final frontier is at risk. Just as we're finally starting to understand its wonders, we're also quickly developing the power to completely destroy it.
Just think about our priorities for a second. We have mapped basically 100% of the surface of Mars in high resolution, a whole other planet. Yet we've only mapped about a quarter of our own planet's seafloor to that same level of detail. The gap in our knowledge is it's enormous.
And into this giant unknown, we're introducing some really serious threats. We're talking about deep-sea mining for rare minerals, fishing practices like bottom trawling that just bulldoze entire ancient ecosystems, plastic pollution that's been found in the deepest trenches, and of course, the overarching effects of climate change.
This quote really says it all, doesn't it? Because we know so little, we are running the very real risk of wiping out entire ecosystems and unique species before we even get a chance to know they exist.
And that leaves us with a really critical question for our generation. As we finally turn our gaze to the largest, last wild place on our own planet, what is our legacy going to be? One of discovery or one of destruction?